Okay, so this is going to be a walkthrough of the current in circuits worksheet, and it's going to be a pretty quick walkthrough. For question 1, first thing we need to look at, is this a series or a parallel circuit? Now, a series circuit is one where there is just one loop of wire, whereas a parallel circuit, as in question 3, is where the wire splits, and there are two options for where those electrons would flow. So circuit 1 is a series circuit because there is just one loop of wire. The rule for a series circuit, for current in a series circuit, is that current is always the same at any point. So if it's 5 amps at ammeter 1, remember an ammeter measures current, then in ammeter 2 it must also be 5 amps. Question 2 then. Again, we need to look, is this a series or a parallel circuit? And in this case, it is a series circuit because there is just one loop of wire. Okay, one loop of wire, series circuit, we know that the current in a series circuit is always the same. So if it's 3 amps at ammeter 2, which measures the current, then at ammeter 1 must also be 3 amps, and ammeter 3 must be 3 amps. Question 3, parallel circuit because the wire splits, goes in two directions. The rule for current in a parallel circuit is that the current splits. So the current that we had before a junction must be the same as the current we have after the junction. So first off, if at ammeter 2 over here we had 4 amps, going into the junction, those 4 amps split in two directions. That does not have to be an equal split. Ammeter 3 over here had 1 amp. That means we started off with 4 amps, 1 amp went this way, so what we're left with is 4 minus that 1 amp gives me 3 amps going through ammeter 4. So that is 3 amps. Then ammeter 3 was 1 amp. That 1 amp joins with the 3 amps over here, and together we get 4 amps. Okay, so 4 amps, which makes sense because there are 4 amps going through ammeter 1, and those 4 amps have not had any other options of where to go, so they must all of those 4 amps must go through ammeter 2. Okay, question 4. Sorry if this is a bit tilted, let me just fold it over briefly. Okay, ammeter 4 then. This one's a bit tricky. Let me have a look. Okay, the first ammeter that I'm going to fill in is ammeter 4 because that's the easiest, and I'll explain why. Ammeter 5 is 1 amp. Okay, so that's ammeter 5 has 1 amp. The current going through ammeter 5, that's 1 amp, has no other option but to go straight through this bulb and continue straight through ammeter 4. So the current along this section of wire must be 1 amp at every point of the wire, which is why ammeter 4 must be 1 amp. Okay, because the 1 amp going through ammeter 5 has no other options to go anywhere else. It must go through the bulb and ammeter 4. Right, I'm just going to add some numbers here to make things easier. Ammeter 6 was 2 amps. Ammeter 5 was 1 amp. We know that's 1 amp. Ammeter 3 is 2 amps as well. Okay, so I've got 2 amps coming through here. That joins with 1 amp, giving me a total of 3 amps passing through here. Those 3 amps join with the 2 amps to give me 5 amps going through ammeter 1, 5 amps, and ammeter 2 then will also have 5 amps. Okay, and those 5 amps split to 2, 1, and 2 amps. Add those numbers together, we get 5. Question 5. This is a series circuit, so the current must be the same throughout. And so this is quite easy to quickly fill in. The little m just means milli. Yeah, a milliamp, so it's just smaller than a whole amp, just 6 milliamps. Okay, question 6. Okay, question 6. Right, where to start? Let's have a look. I'm just going to start off by labeling all the information that I know. So ammeter 5 is 0.5 amps, ammeter 4 is 2.5 amps, and ammeter 1 is 1 amp. Okay. If the current passing through this ammeter is 1 amp, it has had no other option but to pass through the bulb and to pass through ammeter 2. So ammeter 2 must also be 1 amp. Okay, now that 1 amp has joined with the current passing through here to give me a total of 2.5 amps at ammeter 4. So 1 amp plus this number must equal 2.5, which is how I know A3 is 1.5 amps. Then that's 1.5 amps. So I have 2.5 amps over here. 0.5 amps go down this branch. So that means I am left with 2, because 2 minus the 0.5 amps gives me 2 amps going down branch with ammeter 6. Question 7. Let's have a look. Ammeter 1 has 5 amps. I'm just going to write that in. Ammeter 3 has 2.5 amps. And ammeter 5 has 0.5 amps. So I have started with 5 amps over here. Okay, and those 5 amps have split down these branches. What would be an easier place to start, okay, is that in ammeter 3 I have 2.5 amps, okay, and the current passing through there has split between these two options. Over here we have 0.5 amps, so that means I must be left with 2 amps going through ammeter 4, because 2.5 amps have gone in these two directions. 0.5 amps went this way, which means I am left with 2 amps going through this branch. Okay, those two branches add up. So I've got 2 plus 0.5 gives me 2.5 amps passing through here. And the 2.5 amps add with this number to give me a total of 5 amps. So 2.5 plus this number is 5, so this number must be 2.5 amps. Okay, question 8 then. Again, where to start? It looks confusing, so I'm going to just write down all the information I know. A4 is 0.2, A6 is 0.8, and A8 is 0.5. Okay, right. If I look over here at the end, I've got 0.8 amps passing through here, 0.5 amps passing through here. Those two numbers will add together to give me a 5, and that is 1.3 amps. Okay, 0.5 plus 0.8, remember what goes into a junction must come out of the junction. Then, if we look at the same thing in the other direction, 0.5 amps going here, plus the 0.8 amps gives me a total of, again, 1.3 amps. Then those 1.3 amps passing through ammeter 7 add with the 0.2 amps to give me 1.5 amps, okay, which makes sense, so that's how we can check ourselves. 1.5 amps are travelling through here, they have no other option, they do not have any other routes to go. Those 1.5 amps must pass through ammeter 2, 1.5 amps. And again, they must pass through ammeter 1, 1.5 amps. Remember this 1 amp thing over here was for, that was just over for question 6. Okay, so there you have it, there's all the work. The bonus question, V equals IR, that is Ohm's law. V stands for voltage, I stands for current, R stands for resistance. The voltage across this resistor is 6 volts. The resistance is 3 ohms. So we need to rearrange that equation to get the current, because that's what an ammeter measures. So if I rearrange that equation for current, Here is the equation, V equals I times R. I can rearrange that to get I equals V divided by R. I was told the voltage was 6, and I can see that the resistance is 3. 6 divided by 3 is 2 amps. It's a series circuit. We do not include voltmeters when we're considering if it's a series circuit or a parallel circuit, so we can ignore the voltmeter. Okay, so you've just got a series circuit, so the current is the same at every point, and that current is 2 amps. 2 amps and 2 amps. Okay, so there you have it. Here are all the answers for the current in circuits questions. Any more questions, please just let me know.